This reference guide is the third reference guide from Unit 6, and it deals with our first form of equations for lines, which is slope-intercept form. Over the course of this unit, we're going to look at three different forms for these equations. This is the first one that we'll be looking at, and it's one that you may have seen before in earlier grades. So the form slope-intercept form can be written as y equals mx plus b. And this is kind of like a skeleton equation, if you will, where each letter represents something different. M will represent slope, B will represent y-intercept, and that's where the term slope-intercept form comes from. And then x and y will each represent coordinates of a point that lies on that line. Okay, and you can see that information here, where we see that M represents slope, and B represents y-intercept, slope-intercept form. Now this is typically written where we isolate y, so we have y by itself on one side of the equation with no coefficient in front of it. So you will see some problems where you may have a coefficient in front of y, or it may not be that y is by itself. Maybe x is on the same side as y. If you are given questions like that, as we'll see in some of the examples that we do, your first step is to rearrange the equation, get y by itself, and have no coefficient or number in front of y. Now we can see that if we're looking at a graph over here, you can see where you find your y-intercept. As the name implies, it's where the line intercepts the y-axis, or where it crosses over the y-axis. In the example that's there, it would just be at y equals 1. The slope, as we know, is just the rise over run. So it's going to be either up or down and to the right some value. So now, let's take a look at some more of this reference guide. So you're going to be asked to do one of three things typically. You'll be asked to take an equation and plot it on the graph. That's what we're going to do first. You'll be asked to take a graph and make an equation or read something specific, like a y-intercept, let's say, or a slope or something like that from the graph. Or, and we'll see this with the final problems we do, you'll be asked to solve some word problems. So when we're drawing a graph, if the equation is given in slope-intercept form, the first thing you do is you plot the y-intercept. Well, how will I know where that is, you may be asking. Your y-intercept, remember, takes the form of b in the form y equals mx plus b. It will be the constant that lies at the end of the equation, so long as y is isolated and has no coefficient in front of it, as we can see is what's happening in A. Okay, so that will be where you start, your y-intercept, which will be the constant at the end. Once you have your y-intercept identified, we can plot it on the graph. Well, 5 is right there. So there's our y-intercept. And now, we need to come up with at least two other points. Again, you may be saying, how will I know how to do that? Well, as long as y is isolated and has no coefficient in front of it, it's pretty easy to do. You just look at the coefficient or the number in front of x. In this case, it's minus 3. So remember what minus 3 is telling us. That's minus 3 over 1. Well, that means down 3 to the right 1 to get to our next point. So if we start at our y-intercept and we go down 3 and to the right 1, our next point will be right there. From there, we go down 3 more, to the right 1 more, and our next point lies right there. When you're doing this, you need a minimum of 3 points. And I have my minimum of 3 points. If I wanted to do another one, I would go down 3 and to the right 1 once more. And the reason you need a minimum of 3 points is we're going to connect all these dots. We're going to make a line out of this. If you only have 1 or 2 points, well, maybe if you counted wrong, then your entire line will be off. If you have 3 or 4 or 5 points, we know that this should be linear. It's in the form y equals mx plus b, which, as we talked about in Unit 5, will mean that it will be linear. So if we're not getting a straight line, then we've plotted something incorrectly. So using a minimum of 3 points is a good way to just make sure that you have plotted your points correctly. And now remember back to, again, something we talked about before with graphing, which is anytime you draw a graph or plot points and connect them with a line, extend your line across your graph and put arrowheads on the end. Okay? And that's all there is to plotting an equation in the form y equals mx plus b if y is already isolated. It's pretty straightforward. Start with your y-intercept. That will give you a point. Then use your slope to get at least 2 more points. So you have a minimum of 3 points plotted before connecting them. Now when we look at b, it's a little bit more complicated. With b, it's not in the right form. We have a 4 on the same side as y. So we've got to get rid of that 4. Well, if we're adding 4, we're going to get rid of it by subtracting 4 from both sides. So that will leave us with 2y equals 3x minus 4, which is better. Now y is on its own side of the equation, but it's not 1y, it's 2y. So we have to get rid of that 2, which again we do just by dividing out by that coefficient. And we're left with y equals 3 over 2x minus 2. So again, now that we know how to read our equation, this is the slope, 3 over 2. This is the y-intercept. It lies at y equals negative 2. Once it's in that form, now we're going to plot it the same way we did with a. So if our y-intercept is at negative 2, we start by putting a point there. Just be careful with your scale on these axes because it looks like I just put that point at negative 1, but it is at negative 2. It's 2 down from the x-axis. And now our slope is 3 over 2. Well, again, we all know what that means. It means we're going to go up 3 and to the right 2. So let's go up 3 from here, 1, 2, 3, and to the right 2, 1, 2. Then we're going to go from there, so that's 1 point, but we know that we can't do that. We only have 2 points plotted. We need another one. So we go up 3 again, and then to the right 2 again. And now we have that minimum of 3 points that I talked about before. You have to reach that minimum before you can connect them with your line. So once we do that, we take out our ruler, we connect our points, and we draw arrowheads on the end. I actually think I'm going to go, I missed it with my ruler, so I'm very quickly going to replot that because we don't want that one. That wasn't good enough. So we start at negative 2 over 2. Those are 3 points. For whatever reason, missing our points. And we have our line, again, extended and with arrowheads on the end. For whatever reason, it was struggling there to go over the points, but obviously it will be easier with paper and a ruler. Okay, so that's all that there is to taking an equation and plotting it on a graph. You use your slope, you use your y-intercept, and then you develop at least 3 points from there. Now the reverse of what you may need to do is to determine an equation when given a graph. If you're doing this, you'll have to calculate slope. Again, that's just a common theme lately in this course, is you're finding slope in most questions that you do. And you'll need to use the graph to identify your y-intercept. It may be as simple as picking it off of the graph if it crosses perfectly through a point on the y-axis, or you may need to calculate it by setting x equal to 0 if it doesn't pass perfectly through a point, just like we did in the last unit. So let's take a look at some of these questions. So the first graph, we're coming up with an equation for it. Well, let's start simply by coming up with the y-intercept. Well, we can see that it crosses the y-axis right there at y equals negative 1. So that's our y-intercept. It's as easy as just reading the graph. Now we need to find our slope. Well, this is at 0, negative 1. Over here, we're at negative 5, negative 3. So we have our 2 points. We are using our slope formula that we're all so familiar with, y2 minus y1 over x2 minus x1, which is going to be -1, subtract -3, divided by 0, subtract -5, and we get a slope equal to +2 over 5. And again, we can use our graph to make sure that that's right. If we can count up to and over 5, and we end up at that other point, then we'll know that our slope is correct, and it is. So our slope is 2 over 5. Our y-intercept is y equals -1. So when we put it in the form y equals mx plus b, we just start with y. Our m value is the slope, so that's 2/5. And our b value is the y-intercept, so that's -1. So the equation of this line is y equals 2/5 x minus 1. Now let's look at our second one. And we can see everything we need, so I won't scroll up. We can see that our y-intercept lies right there at the origin. Well, that means our y-intercept is equal to 0. We'll talk about that when we get into the equation of the line in a minute. But let's calculate the slope first. Well, you have a whole bunch of points here. Whoever made this graph took the time to make 2 of the points green, so I'll use those as my 2 points. You could use 0, 0 as well. I'll just use the 2 that are clearly outlined. So our points are 2, -2, and -2, 2. So when we figure out our slope, again, we're going y2 minus y1 over x2 minus x1, which gives us -2 subtract 2 over 2 subtract -2. So -2 subtract 2 is -4. 2 subtract -2 is +4. And again, we need to remember to reduce that. -4 divided by 4, anything divided by itself is 1. But we have a negative divided by a positive, so our slope is -1 in this case. So this is going to create an interesting equation. So let's write out what we have, and then we'll figure out if there's some things we don't have to write. So our slope is -1, and our y-intercept is 0. That is the equation of the line, having written everything, but it's not the way you typically see it presented, because you have 2 things there that don't need to be there. We have discussed how a coefficient of 1 in front of a variable does not need to be written. So that 1 we can get rid of. And if you have a constant of 0, that also does not need to be written. It can be implied that that's there if nothing shows up. So the way that we could write this is y equals -x. Again, we get rid of that coefficient of 1. We get rid of that constant of 0. And we end up with this equation. Okay? And it's important to get in the habit of doing that just so that you are doing it properly. And also, so if you see an equation given to you as y equals -x, you know what's implied there. You know that there is a coefficient of 1 in front of the x, and you know that there's a constant of 0 at the end. Okay? And that's all that there is to that style of question. Solving word problems. This is the last thing that we'll do on this reference guide. And this will be a pretty prevalent part of the unit moving forward. So slope-intercept form can be useful in solving word problems. We'll be able to set up equations and solve based on the equation that we create. Remember again that y-intercept occurs when x is equal to 0, and is where the graph will begin. It's kind of a starting point. It's also important to note that anything which changes the x variable will be the slope. So anything that's causing a change or a rate of change will take the place of slope in our equation. So we're going to talk our way through the first one. We won't do too much with it because there is a second one that we will do together. So the first one, the student council sponsors a dance. A ticket costs $5, and the cost of the DJ is $300. Sorry. So we want to find an equation for the profit in P dollars on the sale of the tickets. Well, this P means you use the variable P for profit, and that value will be in dollars. So what we know is that $5 contributes to the profit, and we know that the cost of the DJ takes away from the profit. You have to pay to have a DJ, which is going to hurt your profit. So when we talk about ticket price, we are adding $5 for every person who shows up. That is helping our profit. If nobody shows up, well, we owe $300. So our profit is negative in that case because we have to pay for the DJ no matter what. So that is kind of our starting point. And when we think about it in that way, we can tell quite quickly that every ticket sold changes the profit by $5. So that's going to be our slope. And the DJ, well, that's our starting point. If nobody shows up, we start $300 in the hole. So our negative 300 would be our y-intercept. And you can see that information presented in the equation right there. So again, it's written in function notation. Profit at a certain number of people equals $5 times however many people show up minus $300. So if we consider this in terms of how they would break even, they need at least 60 people to show up before they're back to even. And then they can worry about a profit for every person who shows up above 60 people. So that would be our equation, what's circled in red above. And now we're asked to do a couple of things. And this is some algebra you've seen before, which is nice. Suppose 123 people bought tickets. What was the profit? Well, now we have a number of people, and we've said n is our number of people. So we're saying that our n is 123. So where we see an n in the equation, we're going to sub that in. So 5 times 123 will give us how much money is made from ticket sales, and from that money we subtract the $300 for the DJ. Put all that in the calculator, and again I'm going through this pretty quickly because we're going to do one together momentarily, and we get a profit of $315. Okay, and then we do the, not the reverse, then we do the other type of question that you may see. Now we have a profit of $350. So in this case, our P at n is $350. A profit on a certain number of people is now $350. We want to find out what that certain number of people is. So where we see P at n, we sub that into the equation. We move our 300 over, we divide by 5, and we find out that 130 people attended the dance. And that makes sense, especially given our answer to B, because they're very closely related. If 123 people showed up, the profit was $315. Well, we're told that the profit in part C is $350, which is a bit more than $315. So we know that the number of people that show up should be a bit more than 123, which it is. Okay? It's algebra you've seen before. It's just a matter of now we're setting up the equation before we solve it. So let's do one together now. To join the local gym, Kareem pays a startup fee of $99 plus a monthly fee of $29. Well, we are trying to find the total cost. Well, this is going to affect his cost. That's going to affect his cost. It's not like the problem before where something went for the profit and something went against the profit. He's paying $99. That's a cost. And every month he's paying $29. That's also a cost. So everything here is a cost. You'll also notice in part A that we've been told what the variables are, just like we were in the first question above. We're told that we're using C for cost and N for months. If we're not told that, we have to define our variables. We would have to say, let C represent total cost, and let N represent total number of months at the gym. But since we're not, we don't have to define our variables or state what our variables are. We can just jump into our equation. Again, it's function notation. Well, our cost depends on the number of months. So our cost is dependent. It's our dependent variable. And our number of months is our independent variable. Remember, with function notation, we're going back now a ways. Remember that with function notation, it's dependent variable with independent variable in brackets on the left-hand side, and then our equation on the right-hand side. So our C at n, our cost at a certain number of months, is equal to, well, the change is every month we add $29. So that's changing every month. If we don't go at all, so if we sign up and don't go, we still have to pay this $99 startup fee. So that is our starting point, that 99. So we come up with our equation here. Everything contributes to cost, so everything is a positive. And when we add his number of months times $29 a month to the $99 that he started by paying, we get our answer. So whatever number of months will obviously impact his costs. The more months, it goes without saying, will lead to a higher cost. So now we're saying, suppose he went to the gym for 23 months. That means that our number of months is 23, n equals 23. So we want to find the cost at 23 months, and that's going to be equal to 29 times the number of months, which again we've said is 23, plus 99. So when we work our way through this, we find that 29 times 23 is 667. So we have to go up here. Our our cost at 23 months is going to be 766. It is a word problem, so we do need to write that concluding sentence. Therefore, it cost him $766. Okay? And again, it's algebra you've done before. We started looking at that algebra last unit. But now we have created the equation that we're using, whereas before that was given to us. Last question on this reference guide is suppose the total cost was $505. Well, now we have a C at n value of 505. For how many months did Kareem use the gym? So now we're going to say that 505 equals 29n plus 99. And we need to rearrange this equation and get n by itself. So the first thing we're going to do is we're going to subtract 99 from both sides. We're going to move it over by doing that. So 505 subtract 99 is 406. So we have 406 equals 29n. I'm just going to rewrite it up here so we're not squishing anything in. We don't want 29n, we want 1n. So we divide out the 29. This will give us our number of months. And we find that 406 divided by 29 gives us 14. So therefore, he used the gym for 14 months. Okay? And that is it. Coming up with the equation is the real challenge there. And then after that, it's algebra, but it's repetitive algebra. It's things that we've seen before and things that we'll continue to see.